Today in the workshop, we're checking out the Arduino Giga Display Shield. You'll see how to use this TFT touchscreen display and its integrated IMU, LED, and microphone. There's also a connection for a video camera, and we can use LVGL to create beautiful user interfaces. There's a lot on display today, so welcome to the workshop. Well, hello and welcome to the workshop, and today we are going to be working with a very powerful touchscreen display, the Arduino Giga Display module. Now, as the name implies, this is a module exclusively for the Arduino Giga, so if you're not familiar with the Giga, I suggest you check out the video that I did at the beginning of the year first to bring yourself up to speed. The Giga is the most powerful Arduino there is. It uses the same processor as Arduino uses in its professional Portenta series, and it's the most powerful microcontroller we've ever used in the workshop. It runs circles around the ESP32. By combining the power of the Giga with this powerful display that also includes things like an IMU, a microphone, and a camera connector, we can create a very powerful user interface. So let's go and take a look at some of the features of the Arduino Giga Display Shield. This is an RGB touchscreen display. It measures 4 inches diagonally and has a resolution of 480 by 800 pixels. The display supports both the ArduinoGraphics Library, which is a very simplistic method of putting shapes onto the display, and the GFX Graphics Library, which is a very popular graphics library by Adafruit with lots of different elements and examples available. It's also compatible with the LVGL framework, which is a professional framework for designing graphical user interfaces. We'll be talking about this a little later on in the video. Unlike most shields, this mounts to the underside of the Arduino Giga. In addition to the display itself, the Arduino Giga Display Shield also has an RGB LED, a MEMS microphone, and an extension of the Giga's existing camera connection. The Arduino Giga has 2 connectors in the middle of the board, a camera connector and a display connector. It is these 2 connectors that connect to the Arduino Giga Display Shield. This method allows all of the existing I/O ports to remain available, and you can also use additional conventional shields as well. In addition to the other peripherals, the Arduino Giga Display Shield also has a Bosch BMI 270 6-axis IMU, or inertial measurement unit. This is capable of measuring both acceleration and angular rate. It also has a motion interrupt mode, so it can provide an interrupt whenever the display has been moved. The touchscreen function of the display is provided by a Goodix GT911 touch control chip. This is a capacitive touch controller. It provides for 5 concurrent touch points. You can run the touch controller in an interrupt or an on-request mode. So with all of these features, we can see that the Arduino Giga Display Shield is more than just a simple display. So now let's take a look at one and start using it. And here we have it, the Arduino Giga Display Shield along with an Arduino Giga right next to it. And from the front, there's really not much to see on the shield. It's mostly the display over here, of course. And on the top, you can see the little microphone symbol, and right beside it is the microphone. And a little dot beside that, if you can see that, is actually the RGB LED. And this is the connector for the video camera, and it's actually an extension of this connector over here on the Arduino Giga. It just brings it out so you can mount the camera facing forward. Now, if we flip this board over and let's turn it around, we can see that there's actually an outline of the Arduino Giga over here, and there are a couple of male DuPonts here, some dual male DuPonts, and they fit into these connectors on the Giga board because this mounts underneath the Giga board, not on the top of it like conventional shields, which means that you could also still use a conventional shield with your Giga as well. And as I said, there's an outline of the Giga on this, so let's see if we can do this. Line it up. There we go, and we'll press it down. And there we are. We've installed the Giga onto it. And so we just flip it over, and you've got one unit with the Giga on the back of it and the display on the front of it, and you're ready to go. So now that we've taken a look at our display shield and we've mounted it to the Arduino Giga, it's time to start working with it. To do that, we're going to need to set up our Arduino IDE first. And that's essentially installing the Giga board manager if you haven't done that already, and also installing quite a few libraries. So let me walk you through that, and then after that we'll test out a few of the peripherals that come on the board, things like the LED and the IMU and the microphone, just to get a feel for how we can program for this new display. Now, before we start working with the Giga display, we're going to need to install some libraries, and there are actually 9 libraries that we are going to need, although you may already have a few of them installed. Now, that might sound like a pretty formidable task, but if you do it in the correct order, you actually only need to make 2 installations. So we're going to go into our library manager, and the first thing we're going to type in here is Arduino Giga Display. I've actually got it in my clipboard here. And there we go, Arduino Giga Display. There's a few other things, but the one on the top here is the one you want. Now let's go and install that. And when we install it, it says it also wants to install these other libraries. And so if you say install all, you can save yourself a lot of time over here. And there we go, we've installed all those libraries, and that went by pretty quick. Now there's one more library we're going to need for the camera. And so look for arducam_dvp and install that library as well. And now we're all ready to work with our Arduino Giga display. Now, working with the onboard RGB LED is very simple thanks to the Arduino Giga Display Library. There's a function in it to work with the LED directly. Now, the code is really easy. All you need to do is include the library and then create an RGB object with a Giga Display RGB. And then once you've done that, you just need to initialize the object. We can go into the loop and start using it. And there are 2 things you can do with the RGB object. You can turn it on, or you can turn it off. So we're going to turn it on, and then we get the red, green, and blue values. So we're going to turn on the red pixel at full blast at 255, nothing on the green or the blue pixels. We'll delay for a second to keep it on, then we're going to turn everything off, delay for a second. We're going to do the same thing with the green pixel, and then we're going to do the same thing with the blue, and at the end we're going to turn them all on. And of course you can use various combinations of red, green, and blue to pretty well get any color that you want. But as you can see, it's very easy to work with. So let's load that up and watch our LED flash. And here's the RGB demo, and it's pretty straightforward. You can see that the light is going through all the different segments. There's the white, now there's red, green, and blue. And then all the segments for sort of a white. And of course you can play around with the code. You can have it come on and off for longer. You can change the colors. It's very easy to work with the RGB LED on the Arduino Giga display. Now, working with the IMU is pretty simple thanks to the libraries that have been provided by Arduino and others, and we're going to be using the Arduino BM1270 BMM150 library over here for the IMU. So we're going to include that at the beginning of the sketch, and then we're going to define a Bosch sensor class object called IMU, and we're going to give it a parameter which is where it's connected, and the parameter is wire 1 because this uses the second I2C bus. So you need to do this or it will start looking for the IMU on the primary I2C bus. Now we go into the setup, and it's very simple. We're going to start our serial monitor because that's where we're going to be displaying the 3 different accelerations on the 3 different axes. And we also start the IMU. And then in the loop, we define a variable for the X, Y, and Z axis, or Z axis, depending where you are. And if the acceleration is available, then we'll just read its values. We'll read those 3 values into the variables and print them out to the serial monitor. So once again, the library makes this a very simple device to use. So let's load it up and see what results we get. And so the IMU acceleration code has been loaded up to the Arduino Giga, and the IMU measurements, as you can see, are on the serial monitor right now. And if I were to accelerate this in a direction, we can see that they change. We've got a negative number, we've got some negative and positive ones. If I flip this over, I can make my negative at the end into a positive and the positive at the beginning into a negative. So it is indeed working. It's measuring acceleration along all three axes. And you can use this data with the display if you wish in order to make a display that reacts to movement. That would be great for some sort of a game or something. And so this is another very useful feature of the Arduino Giga Display Shield. Now the next peripheral on the Arduino Giga display that I want to check out is the microphone. There are a couple of different ways we could do this. Now there is some sample code included that you can certainly run if you wish that will give you the output of the microphone on the serial monitor, and you could also use the serial plotter to look at it. Personally, I find that to be a bit confusing, especially as the serial plotter doesn't allow you to fix the y-axis. It's variable, and so you don't really see that oscilloscope type of display that you might hope to see from a microphone. Instead, I've got this example, and this is some code that was provided by Arduino. I've just formatted it a little better and made one change to it. And what it does is it displays the audio level from the microphone on a bar graph display on the display. And I think that's a lot nicer to see. Plus, of course, we are working with a display. It's about time we displayed something. And so we're going to start off by including some libraries. The PDM library is what you need to work with the audio. And then this library is what you need to work with the video, the Arduino H7 video library. Now the LVGL library is something we're going to be talking about a little later. LVGL is a graphics library. It's also a graphics framework. And all we really need to know about it right now is that it's capable of creating objects such as controls, and in our case, a bar graph. Now we're going to set up a display object for the video display, and this is our video display, and so you'll notice this is how we're going to pretty well set it up on everything that has to use the display. So we've got the display size and the type of display we're using. Now this is a slider that LVGL is going to define. So here's a slider definition here, and these are definitions we're going to need for the audio. We're going to be using one output channel because we can also use stereo, but we're using one. And the input frequency, this is the amount that we're sampling by, and that's 16 kilohertz. So we're going to sample at 16 kilohertz, and this is the sample buffer that we're also going to define here as well. And here's a volatile integer that's going to read back the number of samples that we have read. A couple of other definitions here, and then we go into our setup. In the setup, we begin to display, and here's where we set up a callback for PDM. In other words, whenever we receive a signal on the microphone, we're going to call this on PDM data routine, and we'll look at that in a couple of seconds. Now we're going to start the PDM over here, and then we're going to create the bar graph, and these are just parameters that we're going to use for the size and operation of the bar graph. Now before we go into the loop, let's go and take a look at that callback function. And the callback function, which is called every time that we receive data on the microphone, is going to query the number of available bytes that we've got, and it's going to read that into a sample buffer, and it's going to change samples read to the number of samples that we have. And so now that we know about our callback, we'll go back into the loop, and we're going to look in the loop and see if we have read samples. And if that is a value bigger than 0, then we have read samples. And then we're going to just print those samples out to the serial monitor, but we're also going to print it out to the plotter, and that's what we really want to do down over here, is print it to the plotter. Now the only thing I changed, as I said, I changed something on this to make it a bit different, and that was this value over here, this 10 value. It used to be higher. I think it was actually 100 in the original code, but I found that it wasn't sensitive enough. So you can play with this if you wish to adjust the sensitivity of the bar graph. But otherwise, that's it for the code. We're just going to load it up and see if we can see a bar graph dancing along with our microphone. And here's our bar graph display, displaying the sound from the microphone. And as you can see, as I'm talking, you can see the reaction on the bar graph. So it does seem to work. Now, of course, there's a lot of uses for the microphone other than just driving a bar graph. This is a very powerful processor after all. So things like voice recognition are child's play for a device like this. And having it right there on the display module can make for a very powerful user interface. Okay, now that we've experimented with the peripherals, it's time to actually put something onto the display. After all, that's what we want to be able to do, right? We want to be able to display text. We want to be able to display shapes and colors. We even might want to be able to display images. And there's a number of different ways that we can do that with this display. The simplest way of doing that is to use the Arduino Graphics Library. This is a very small library. It's quite efficient. It doesn't have as many features as some of the more full-featured libraries, but for creating simple user interfaces, it may be all that you need. So let's go and experiment with the Arduino Graphics Library. The Arduino Giga Display Shield uses a TFT display that has a 480 by 800 pixel resolution. It supports 16.7 million colors and has a 0.108 millimeter pixel size. This is a capacitive touch display, and it provides support for both 5-point touch and gestures. It also has an edge LED backlight. You can see the coordinates on the display here, and this is the coordinate system we will be using when we program it for graphics. The simplest method of programming graphics is to use the Arduino Graphics Library. This is a simple graphics library that allows you to draw and write on the screen using graphics primitives. This is easy to use for making simple shapes and graphics. The syntax of the Arduino Graphics Library is very similar to the Processing 3 GUI design program. So now let's use the Arduino Graphics Library to make graphics on our display. Now here's a very simple demonstration of the Arduino Graphics Library, and I want you to note how easy it is to use and put simple shapes onto the display. Now you're not going to do anything fancy with this, but you can do quite a few things. And so we're going to start by including the required library, the Arduino H7 Video Library, and the Arduino Graphics Library itself. Then we're going to create a display object using the H7 Video class, and we're going to give it the size of the display and the type of display, which in our case is Giga Display Shield. And then we'll move into the setup, and the entire program is going to run in the setup. So we're going to initialize our display with a display begin, and we're going to start drawing. And the first thing we're going to draw is a red rectangle, and it's going to cover the entire display. So every time we start drawing, we're going to want to use these three commands first: begin, draw, a clear, and a no stroke. And then we'll fill our color, and so we're going to fill it with red. So that's what we're doing over here. Of course, you could change the RGB values to anything else that you like. And then we're going to use that to display a rectangle. And the first two entries are the coordinates for the rectangle. 0 and 0 is the top corner. And then the size of it is going to be the width and the height of the entire display. So this will fill the entire display with a red rectangle. Then after that, we're going to draw a blue circle that's 200 pixels in diameter. And we're also going to put it at coordinates 200, 200. And so we're going to fill our display with blue, and then we're going to display a circle over here. And as with the last one, the first two sets of numbers here are the coordinates 200, 200, and the last 200 over here is the size of the blue circle. And then we're going to draw a 300 pixel green circle at some different coordinates, 500, 300. So once again, we fill the display with green, and then we draw our circle at 500, 300, and it's 300 pixels wide. And now that we've put everything into that, we're going to say end draw, and it's going to produce our drawing. And that's it. There's nothing in the loop. And so let's load this up and look at the pretty colors on our display. And here's the result of our simple Arduino graphics test, and it's pretty well what you would expect. The red rectangle in the background filling the entire screen, and the smaller blue circle and the larger green circle. Now you could experiment with the code, of course, change the colors, change the shapes, change their positions, and you'll get a pretty good idea of how to use the Arduino graphics library to draw very simple graphics on the Giga display. Now, another great use of the Arduino Graphics Library is for displaying image files on your display, and that, of course, can be very useful if you have a logo or something that you want to place on your display. And so this example file is going to place the Arduino logo on the display, and after that, we'll take a look at how we can change that to our own logo. Now, it's going to be using the same two libraries we did in the last example, the H7 Video and Arduino Graphics Library. It also includes another file which is over over here, and this is the ink bin. And ink bin is a number of utilities that can be used to convert these graphics files into a format that can be used by Arduino Graphics. Another thing it includes is the logo itself, and that's this file over here. And as I said, I'll show you how you can use your own logo instead of the Arduino one in just a few moments. Now, otherwise, the sketch is pretty simple because a lot of the work is done in ink bin, and the rest is done by the Arduino Graphics Library. They have some text over here for how you can place your own file in there, and we'll be doing that in a minute. But first of all, let's take a look at this one. Now, just like the last sketch, we define a display object with the size of the display, and Giga Display Shield is the type of the display. And then we also define an image object that we're calling Image Arduino Logo, and this gives the parameter of the image and its size. Now, everything here is done in setup once again, so we're going to start our display. We do a begin draw, and then we're going to display an image, and here's the image we're displaying. And after that, we just have the parameters of the image itself and the position we want to place it. And then we do an end draw, and that's it. That'll put the image up on the screen. So let's load that up, take a look at the image, and then see how we can modify it to use our own image. And so after loading the sketch up to our display, we can see that it's displaying the familiar Arduino logo. And you also have another option for displaying the Arduino logo. If you look in some of the example files, they will show you how to use the Arduino Graphics Library with a number of graphics primitives, such as circles and lines, in order to create an Arduino Graphics logo. And so that's great if you want to display the Arduino logo, but of course you probably have something else you want to display other than that. So now let's take a look at what it would take in order to display our own image on the Arduino Giga Display module. Now, the first step in putting your own image onto the display is to create it in the correct file format, which in this case is a .bin file. And we can use this online image converter, this is the one that is linked to in the sketch, in order to make that conversion. Now, as it says, it'll work with bitmaps, JPEGs, PNGs, or SVG files to convert them to C arrays or binary files, and we're going to be using a binary file. Now, we need an image, and remember the size of the display is 480 by 800, so don't select an image that's going to be larger than that, and it has to be one of those file formats. So let's go and select an image over here. I'll go into my pictures directory, and we'll get my red-armed robot. And he's my selected file, and this is the file name. You can change the file name on the output if you want, or just leave it the same. Leave the color format where it is, but here where it says output format, you're going to need to change that to binary RGB 565. And then other than that, you just hit the convert button and say where you want to save it. I'll save it in my downloads file, and it's being downloaded. And so remember where you save the file, because you're going to need the exact file location for the next step. And we're back in the IDE with what is essentially the same as the example sketch, but it's been modified to use the file that we just downloaded. So I'll show you what the modifications are. We start off the same way with the same libraries included, but you'll notice one thing we don't include is the file with the Arduino logo, which of course we no longer need, and it's no longer part of the files in here. However, we still need the ink bin file because that has all the utilities to convert the binary file for us. And so over here is where we change things. Instead of calling up the Arduino logo file, we'll include ink bin, and then we do this. We have the path of our file over here. So you remember that's where I downloaded my file to, and so of course you're going to need to replace that with the path to your own bin file. And then we create the display object as we did before, and here we define the image. Now, it was called Image Arduino Logo. I changed it to Image Robot, but a name by any other name, as you know. Now, it also has some parameters at the end that you're going to want to change, and you need to change that to the size of the image. If you don't, that's going to be the size of your image, and it'll stretch or compress the image to fit that, so make sure you get it. Now, in my case, the image size happens to be part of the file name, but of course it doesn't have to be, so you should know the size of your image in pixels for that. And then after that, it's pretty simple. We just start the display, and down over here is where we draw the image, and we're going to to draw it at a location in the center of the display, and that's why we take the height and the width of the display and divide them in half. But you can change that to put that in any spot on your display. So let's just load that up and take a look and see if we've got our robot instead of an Arduino logo. And so I've loaded everything up to the Arduino Giga Display Shield, and as you can see, the image of the Arduino logo has now been replaced with my familiar red-armed robot. And so this technique works pretty well, and you can use it to display just about any image on this display. Now, the Arduino Graphics Library is certainly capable of performing a number of functions for the display. However, if you want to take it a step further, what you can do is use one of the most popular graphics library that there is for microcontrollers, and that's Adafruit's GFX Graphics Library. This library has been around for a long time. We've used it several times here in the workshop, and it's a great way to program your display. Because it's an Adafruit product, there's some excellent documentation out there, and there are thousands of examples to get you going as well. So let's go and take a look at the features and capabilities of the GFX Graphics Library with the Arduino Giga Display Shield. This popular graphics library was developed by Adafruit to standardize graphics across all of their various display devices. It has since been expanded to include a number of non-Adafruit displays as well. The GFX Graphics Library has all of the basic drawing functions and shapes, and it is also capable of displaying bitmap images. This library will work with a variety of displays, including OLED, TFT, and LCD, and it works with both monochrome and color displays. Now, this is an example of the classic GFX test, and we've seen this example run a couple of different times on different displays. The only difference here is it's been modified for the Arduino Giga display, and in fact, if you look at the code, you can see it was really written for a different display, but it works with this one. And so we won't go through all the code bit by bit. There's a lot of it here, and we've seen it before, but we'll go through the main sections. We define a few colors over here after loading the library and defining a display object over here, which we're calling TFT in this case, again because this was code from a different display. Then we go into the setup, we set up our serial monitor, and we write a number of different parameters on the serial monitor, and we call a number of different functions that are later in the code, such as test fill screen, test text, etc., etc. And as we call them, we are going to print out on the serial monitor which one we are actually calling. So we display a number of different things on our display during the setup, and then we move into the loop. And in the loop, we'll go and do a rotation, because the way that this is going to work is we're going to go through the setup, do a whole bunch of different displays, triangles, rectangles, etc., different sizes, and then we're going to go into the loop and we're just going to rotate it. And what's going to be rotated at the end is actually some text from the Hitchhiker's Guide to the Galaxy, some Vogon poetry, which of course most of you know is the third worst in the world. At any rate, that's buried in one of the functions below here, and that's what these all are, just functions over here. So here's one to fill the screen, here's the text function, etc. And you can look at all of these functions. Remember, our object is called TFT, even though it's a Giga display. And you can see how we would work with the display. Like here, for example, is the Vogon poetry that I just referred to over here. And here's one where we test lines, and here's one where we fill the display, etc., etc. So you can go through all of these and see how it works. And again, we've done this before. So let's go load this up to our display and watch all the pretty patterns. And so I've loaded up the demo, and it's running right now, and it's going through all of those different functions it calls through setup, and those functions draw a number of different geometric shapes. And when it finishes that, which it should be doing very soon, there you go, it's in the loop. And now it's just showing some text, as I said, the Vogon poetry, and it's in different fonts and it's in different orientations, and this will continue forever and ever. Now, of course, we've seen this demonstration before on different displays, so we can kind of compare the quality of the display on the Arduino Giga display to other ones, and it is, of course, very good quality. And so it also illustrates how you can do just about everything you want to with the GFX library. There are tons of examples for that library online. It's a Adafruit library, so naturally it's very well documented. So you could really do a lot of interesting graphics on the display using the GFX library. Now, aside from the two graphics libraries that we've just looked at, there's a third method of producing graphics and creating user interfaces for the Arduino Giga Display Shield, and that is a product called LVGL. LVGL is actually a graphics library and a graphics framework. It allows you to use an external editor if you want in order to design very sophisticated user interfaces that you can then compile and use. You can also use it on its own without the editor. So let's go and take a look at some of the features of LVGL, and then we'll run a demo that can illustrate just how powerful it can be when it's coupled with the Arduino Giga Display Shield. LVGL is the Light and Versatile Graphics Library. This is an open source design on the MIT license, so you're free to modify the source code if you wish. It'll work on any microcontroller over 64 MHz, and it works with multiple languages, both linguistic languages and programming languages. The LVGL library is packaged with over 30 widgets. These are controls and displays, and these are the same types of controls and displays used on commercial apps for smartphones and tablets, so you can build some very interesting user interfaces. One unique feature of these widgets is they are used in real time. They only come into memory when they are in use, and this saves a lot of memory and increases performance. LVGL has a number of different rendering options, including vector graphics, arcs, lines, and shapes. In addition, it has over 100 preset styles that you can use for your display. To simplify design with LVGL, you can use SquareLine Studio. This is a UI editor tool specifically made for LVGL. It uses a drag and drop interface to make designing your screen very easy. It also can export C or MicroPython code. SquareLine Studio is a free download for Windows, Mac OS, or Linux. SquareLine Studio has a number of different plans for developers, but there's also a personal use plan that is free. We'll be making use today of the LVGL library. This is a portable C library that is C++ compatible and has no external dependencies. The library comes complete with over 100 examples, so there's a lot of code that you can go through for your designs. The library is compatible with a number of different microcontrollers, including, of course, the Arduino Giga. Now, a good way for getting a feel of working with LVGL and the display is to use the LVGL demo that has been included with the Giga display. Now, this demonstration will show you how you can create a number of different widgets on the display and how you can also get feedback from some of them as well. Now, we're going to start off with the H7 video, of course, and the Giga Display Touch as we have before, and we'll also include the LVGL library. We're going to enable the video display over here. This is where we define it, and here we're also defining an object for the touch detector, and we'll be working with the touch in a bit more detail just a bit further on in this video. Now, there are two callbacks over here. There's one for a button click event, and this is whenever you click one of the buttons, because we're going to make a bunch of both checkboxes and radio buttons on here, and this will get fired every time one of these is pressed. And here's another callback. This is when the slider is moved, because there's also a slider control in this demo, and so whenever it is moved, this will be called as well. Okay, we're going to go into setup, set up the serial monitor, of course, set up the display, and set up the touch detector. Now we're going to create a container with a 2x2 grid, and so what this means is we're going to have 4 separate sections inside our display, and so this is how LVGL can set this up with the coordinates and everything, and you can take a look at the code and play with the numbers and see what the effect is on the display, and that's a great way to learn about this stuff. And then we go and fill those containers. Now, the first container, the one at 0, 0 in the top left, we're going to place an image. You'll notice that we've also included the Arduino logo image here again, and so this is the code we're going to need in order to place that image there, and it's actually not that much code at all, so you can take a look at that. And of course, you could create another image of your own. You could use the utility we had before and output it as a C file, and then just use this in order to replace it with your image. Now, here's the checkboxes and buttons, and these are going to go in the top right grid. And so it's in section 1.0. And so here we're going to create a number of checkboxes and buttons, and then we're going to populate them with devices. And we're also going to change the status of one of them to already being checked in the checkboxes. And so this is all for checkboxes and buttons and for the feedback that we're going to get from them, because if we have a clicked event, we're going to have to call that routine that we saw earlier. Now here's slider, and the slider is going to go on the bottom left side, and this is all the parameters we're going to be using for a slider control, including the feedback that we get there as well. And the final one is a bar graph. We're just going to drive the bar graph with some random data over here. And so this sets up all the parameters of the bar graph. And you can go through the LVGL library documentation, which is quite extensive, and look at all of these, and you'll see what all of these different functions do for like a bar graph, for like a switch, etc., etc. And you can play with them and also, of course, change them around then and see what the effect is. Again, it's a great way to learn. Now, in the loop, there's only one thing. It's the LV timer handler. And this is the only thing you need to call in the loop for LVGL. So your loop is free to do everything else. This is the only thing you call for graphics. And that's one thing that makes this really great. So let's load up this demo and take a look at all the different controls that we can display using LVGL. And here's the resulting LVGL demo, and I think after looking at the code, you can see the different segments, the image over here, the radio buttons and checkboxes over here. We've got a slider over here and a bar graph over here that's just automatically going up and down. Now these are functional. You can drag these if you wish. And these are also functional, but very, very tiny. A little hard to use, but you can use them. And these, of course, are just a few of the many controls that you can get with LVGL. And whether you design just using the controls that are in the library, or whether you make use of Squareline Studio to make a really interesting interface, you'll be able to create an amazing interface for the Arduino Giga Display Shield. Now, when you install the Arduino H7 video library, it also installs a number of example sketches, including several of them that can be used with LVGL. And this is an interesting one. It's called IMU orientation. And as its name implies, it's going to use data from the IMU to set the orientation on an image that it has on the display. Now, the image, again, is the Arduino logo, and that's included as a second C file over here, which also includes a number of definitions, and this is the logo over here. Now, the sketch itself is actually fairly simple. First of all, it includes the library for the IMU over here, and then the library for the H7 video, and the LVGL library. Then we set up a video display object and give it the parameters of the Giga Display Shield, and we also set up the IMU. And then we go and declare an image, and this is the image over here, the image Arduino logo, and it's declared by the fact that it is in the same directory as the INO file. So if you're going to be changing to a different image, you'll have to keep that in mind. We define an image variable over here, and in setup, we set up a serial monitor, we set the display to begin, and we set the IMU to begin. And now what we're doing is we're setting a container for the image over here. So we do that here. And then we set the source to fill that container with, and that's the Arduino logo. And now we set the alignment of that image, and we're going to set the alignment in the center of the screen. And we'll also set the pivot of the image. And the pivot of the image is going to be set with the X and Y coordinates that we provide over here. And right now it's in the center of the screen, with the X and Y being the header width and header height defined in half. Now we'll set a value for the rotation constant over here, and we'll go into the loop. Now in the loop, we do the same thing we did with the IMU as we did before. We get some variables for the X, Y, and Z axis, and we see if there's any acceleration data available. And if it's available, we read those values into the axis, but we trim them so they don't go above negative or positive 0.8 for the Z axis. And then after that, we compute the rotation angle, and that's what this whole line of math math over here does, and then we use it to set the angle on the image. And down here we just have again the handler that needs to be called all the time in the loop whenever you're using the LVGL library. So the code is actually fairly simple. Let's load it up and see if it works. So I've loaded the sketch up to the board and we can see the Arduino symbol on the display. Now let's just pick this up and rotate it. And as you can see, the display rotates as you move it. So the IMU data is being used to set the orientation of the image. And of course, you could use this technique in your own designs as well. So we've been working with the graphics on this display for a little while, but now I want to go and focus on the touchscreen aspect of the display. The LVGL demo did indeed use the touchscreen, but it wasn't really apparent how you use it, and it's actually pretty easy to use thanks to an Arduino library. There are two different ways that you can get touchscreen data from this display. Let's go and take a look at them. The capacitive touchscreen on the Arduino Giga display can be divided into coordinates, and we've already seen what the coordinates are at the corner. Sometimes it's more helpful to look at this as a grid. And when we look at it this way, we can see that if we touch specific spots on the screen, we will produce a set of X and Y coordinates. The Arduino Giga Display Touch library can receive those touch point coordinates for us. It's capable of capturing up to 5 concurrent touch points, so we can use things like gestures in our design. The library can be run in 2 different modes, interrupt or on request, and we're going to take a look at code for both of those modes now. Now, the first method of working with the touchscreen that we're going to examine is the polling method. And the polling method is pretty well like the kid in the back seat on the long car trip who keeps saying, "Are we there yet? Are we there yet? Are we there yet?" With polling, we just keep polling the screen to say, "Is someone touching me? Is someone touching me?" And if they are, we grab all the coordinates. And remember, this library is capable of grabbing up to 5 concurrent touch points. And so it's very simple code. We include the library itself, and then we define an object for the touch detector. Then we go into the setup and we set our serial monitor up, and we set up the touch detector as well. We just do a start on it and print that it's okay. Then we go into the loop and we define an integer, which is contacts. Now, these contacts are the number of different points that we are touching right now. We also define an array that specifies what those points are. And then the contacts are going to equal touch detector, and then we use the get contact points method to get the number of points that we have. So we know how many contact points have been contacted. And if that number is greater than 0, then someone is touching us with 1 or more fingers. And so we will print out to the serial display the number of contacts, and then we will go through that array and display the X and Y positions of all of those contacts. So we'll display up to 5 different points if necessary. Then we'll delay for a very short period and go through it again. So it's quite easy to do. Of course, one problem with a polling design, though, is that you probably want to do other things in the loop. And so if the other things in the loop take too long, you may miss picking up something on the screen. But otherwise, this is a very easy way of doing things. So let's load this up and check it out. And so I've loaded the touch controller sketch up to the Arduino, and we're ready to test it out. As you can see from the serial monitor, it says the controller initialized okay, so let's just touch the corner. And you can see I'm getting my X and Y coordinates there. I'll touch a corner up over here, and I get much larger X and Y coordinates. And of course, anywhere on the display I touch, I get the X and Y coordinates. Now I can use 2 fingers here. I can spread them apart, and as I do, every movement I make, I'm getting the results on the screen so that I could use this for gestures. I could even place more than 2 fingers on if I want to, and we're able to pick it up. And so it seems to work pretty well. However, it is not the only method that we can use for getting touchscreen data from the screen. In fact, there's a method that I like even better, and we're going to take a look at that right now. Now here's the code that we'll be using for the interrupt method of using the touchscreen. And I like this method better because what happens with this method is you only get an interrupt if the screen is touched, and then you go and handle the interrupt. Otherwise, you can ignore the touchscreen and your code can go on as usual. Once again, we do the same thing we did in the last sketch. We'll include the library and we'll create an object to represent our touch detector. And then we have a GigaTouch handler. This is the function of our interrupt handler, and this is going to be called every time that the screen has been touched. And so we're passing to that the number of contacts and the points, and in that handler we're just going to print out the contacts, and we're going to print out only the first touch point. We're not going to go through the whole thing like we did before, but that doesn't mean that data isn't available. We're just doing this very quickly because I suspect they wanted to design this so they were in the serial print as quickly as possible, because this is an interrupt handler, and serial prints really aren't the sort of thing you should do in an interrupt handler. But of course, this is just a demo. Now in the setup, we set up the serial monitor and touch detector exactly as we did before, and we also do an on detect and pass the value of our interrupt handler. So this is how we tell it that this is the interrupt handler to service every touch. And then there is nothing to do in the loop because everything has been done in this interrupt handler here. Whenever the display is touched, this code will run. So let's load it up to the display and give it a touch and see what happens. And so now I've loaded the interrupt-based version of the touch controller up, and once again my serial monitor says it's initialized all right. And I'll give it a touch, and I am indeed getting my result back. It's telling me I've got one contact, and it gives me the coordinates, and I can do the same thing up over here, pretty well the same as before. Now if I use two fingers, it's telling me that I have two fingers, but because of the way the code is written, we're only displaying the first coordinate. And so that doesn't mean we're not getting the data for the other coordinates. I want to be clear on that. We're getting all of the data. We're just only displaying one coordinate. So this does seem to work well, and it also, as I had said, has a number of advantages over the polling method, because with the interrupt method, your program is free to do whatever it wants, and it doesn't have to do anything with the touch screen until you actually touch it. Now, one of the more interesting features of the Arduino Giga board was its camera connector. It has an SPI bus camera connector, and it can be used with a number of different ArduCam cameras. When we originally reviewed the Arduino Giga, the camera was not really functional. The examples that they provided would not work, but now they have improved it and it does indeed work. And on the Arduino Giga Display Shield, they've extended the camera connector so that you can mount the camera facing the user of the display shield. This would be really great for a point of entry terminal. Remember, you also have a microphone at your disposal here as well. And so what we're going to do now is take a look at that camera connector. We'll see what kind of cameras we can use with this, and then we'll do a little experiment and a demo with a camera with the Arduino Giga Display Shield. The camera connection on the Arduino Giga display is simply an extension of the existing camera connection on the Arduino Giga. This type of camera connection uses an SPI bus for image data and an I2C bus for control data. This connector is compatible with a number of ArduCam cameras, including 4 cameras specified for use with the Arduino Giga. The ArduCam HM01B0 is a small 0.1 megapixel monochrome camera that only has a resolution of 320 by 320. This is not the type of camera you would be using for taking pictures. However, for image and gesture recognition, this is ideal. The ArduCam HM0360 is a 0.3 megapixel color camera with VGA resolution and a 64-degree field of view. The ArduCam OV7675 has similar specifications. This is a very inexpensive camera, and it's the one that we're going to be using in our experiments today. And finally, the ArduCam GC2145 is a 2 megapixel color camera. It has a resolution of 1616 by 1232 and an 80-degree field of view. Now, when you install the Arduino Giga Board Manager, it also installs a number of code samples, and 4 of these samples are for the camera. We're looking at the Giga Camera Display example right now. Now, remember, this was originally written just to be used on a display attached to the Giga with the camera installed on the Giga Camera connector. And I'm bringing that up because there is a function in here that makes no sense for the display, and you'll see that in a moment. Now, the first thing we need to do is define the type of camera that we have, and as you recall, there are 4 cameras we can use with our Giga. Now, the one they've defined is not the one I'm using. So this is the camera I'm using, the ArduCam camera OV767X, it says. It's actually a 7.6. So what I'm going to do is copy that and replace this over here with it. And that way I've defined my camera connect correctly. So you'll have to do that, of course, or it's just not going to work. After that, to define a frame buffer for the camera, there's 2 buffers, one to capture the frame and one to rotate and resize it. That, by the way, I think there might be a slight error in their code. You'll see that when I do the demo. Then we set up the display as we have before. Now, there's a function here called blink LED, and this is why I was saying, remember, this was written not for the display, but just for the Giga board, because they're going to use the LED blinking as a indicator when there's a problem with the camera. Of course, the built-in LED is on the Giga board, which when you have the display mounted is on the back, so you're not going to see this anyway, but that's what this is, and this is basically a function, which is the blink sketch. And over here, we're going to go into our setup. We're going to set up the camera itself, and we're going to set up the palette over here. And this converts an 8-bit grayscale to a 32-bit grayscale. We're going to start our display, and we're going to set our output buffer up. Then we're going to clear our display so it looks nice and pretty. And then in the loop, this is where we're going to actually grab the frame buffer. And this is the routine I think there may be a little issue of. This is where we take the frame buffer, dump it into another buffer that we're then going to store. It also scales and rotates it, and I think in the rotation side there's something a little off. At least you'll see that when I do the display. And then after that, we just draw the image out to the display, and we finish off. If we don't get data, we go and run that blink LED routine, which of course will blink the onboard LED, which we can't see from the front anyway. This isn't going to work with the LED that's on the display. Of course, you could easily modify it to do so, but we're really here just to test the camera. So let's go and load this up to the Arduino and take a look at it. And so I've installed the camera onto the Giga display, and I've loaded our sketch to it, and you can see the results right now. Now you can see the camera is mounted on the top on the camera connector facing outward. It's the only way it will mount. You can physically mount it the other way, but it won't work. This is the only way it'll work. And I've got another one of the cameras over here. This is a very inexpensive camera. This is the 1.3 megapixel version, the VGA version. And I think this cost me about $5 or $6. Very inexpensive and not much to it. Just a camera module and a connector on the back, a couple of chips over here, and that's it. You probably also could extend the camera if you wanted to with a small ribbon cable if you didn't want to mount it where it is right now. Now, as you can see, we've got a picture going here, but as I inferred in the code, there's something wrong with the picture. Now, the quality of the picture is actually quite good, and you can see some of the recording equipment up over there. I don't know if you can try to read the lettering on the cameras, but if you can, you might see the problem I'm inferring to. And I've got the box over here. I think this will show it off pretty good. If I hold this up here, you can see everything is upside down. It's backwards. And so my display is backwards. It's also not centered. And I'm pretty certain that section of code that I showed you is what's responsible. There's probably a plus that should be a minus, or a greater than that should be an equals. It'll be something small like that. Otherwise, the quality of the video is very, very good. Now remember, this is just the VGA 1.3 megapixel camera, and you can get a higher quality camera for this as well. So this certainly has a lot of potential for a point of entry terminal or something where you're trying to do face recognition or gestures or something like that. It's a great addition to this display. Now to summarize, the Arduino Giga Display Shield is a very powerful color display. Its touchscreen capabilities are excellent. It can display video. Combined with the Arduino Giga, it is a very powerful combination. And personally, I'm going to be using this with an Arduino Cloud project that I'm building right now. I think it'll make an excellent central control panel. However, I think I do need to address what is the elephant in the room, so to speak, the cost of all of this. When you consider that this display, which is not that inexpensive, is coupled only with the Arduino Giga, which is also a very expensive controller, this is priced a little higher than many hobbyists can afford. And so I understand that. And for people who can't afford this display, obviously there are other solutions. There are conventional LCD displays that you can use with the Arduino Mega at a lot less cost, but of course a lot less capability. This display also brings you into the price range of some of the Raspberry Pis coupled with displays. So you'll have to decide whether the value is there for you or not. For me, it is. As I said, I want to build a control panel for the Arduino IoT Cloud, and I think this thing will be perfect for it, but you'll have to make that decision yourself. At any rate, if you'd like to get a bit more information about this display, or if you want to grab the code that I used today, you'll find that on the article in the dronebotworkshop.com website, and there is of course a link to that article right below this video. While you're on the website, if you haven't yet, please consider signing up for my newsletter. No, it is not a sales letter. It's just my way of occasionally letting you know what's going on in the workshop. And one thing we just started in the newsletter is I'm also giving you a few previews of the subjects that I'll be doing in my video. So if that interests you, by all means, please sign up. If you'd like to discuss this some more, a great place to do that is the DroneBot Workshop forums, another thing that's free to sign up for, and you can discuss this and other electronics issues with a number of like-minded individuals who are happy to help you with your problems. And finally, if you haven't yet, please subscribe to the YouTube channel. I make videos about electronics and microcontrollers, and if you enjoyed this video, I'm sure you'll enjoy my other ones. All you need to do to subscribe is to hit that red subscribe button, and if you click on that bell notification, you will be notified every time that I make a new video. That is, of course, if you've enabled notifications on YouTube in the first place. And so until we meet again, please take good care of yourself, please stay safe out there, and I will see you soon here in the DroneBot Workshop. Goodbye for now.